Okay, so we're going to start looking at multiplying complex numbers and how that affects their representation on an Argand diagram, and to see if that leads us to a better intuition about how this works. So we're going to do this in 3 stages, building up to it. We're going to start with a complex number z, 4 plus 3i, which is 4 real and 3 imaginary up here. We're going to look at multiplying it by just some natural numbers, which should have an effect that you understand naturally. So we'll start with multiplying by 1. A lots of z then here is just one lot of 4 plus 3i. Expand the bracket and you get 4 plus 3i. So AZ is z. So just like with our traditional numbers on the number line, multiplying by 1 does nothing because 1 is the identity. Multiplying by 1 does nothing. So we'll look at doubling it now. So we've got b worth 2. So we're going to work out 2 lots of 4 plus 3i, which is 8 plus 6i. Plot that on here, 8 plus 6i is there. So that is b lots of z. Okay, and you want to think about properties of that number and what that looks like going forward. While we're at it, let's look at a different complex number. We're going to do c lots of w. So c is 5. W is here, is this small number, which is negative 0.7 plus 2.4i. Again, expand the bracket, and we get negative 3.5 plus 12i. So negative 3.5 plus 12i is there. So that is CW. So, what does this have to do with that? And what does this thing over here have to do with that? Well, you will spot they'll sit on the same argument. Just do some colour coding here. They sit at the same argument, and these sit at the same argument. Okay, so multiplying through by a real number doesn't have any effect on the argument. There's no rotational stuff going on, and that was the original size of z. And this is the size of bz. And you'll notice that that length is double that length, not a surprise, because b was worth 2. A similar way, this length here and this length here, well, this long one is in fact 5 of those. You can measure it and check. So it looks like multiplying by a scalar has a scaling effect. Shouldn't be a surprise just from linguistics, but it's nice to see it confirmed visually. Multiplying by a simple number from the number line, it just scales a complex number out from the origin so that its size changes.